Well, thank you all for joining us. Thank you, Nick, for agreeing to do another episode of JMI TV. I'm your host, Andrew Zimmer, and today we're going to talk about the Amatec Drexelbrook line. There is a wide variety of level products, and we're going to touch on the best ones, or at least all the ones that we can touch on. Let's get right into it, Nick. So the first product that we have is we can do it any temperature, anytime. We do the tough applications. I think that's fair to say. And so here we're going to talk about a point level product where we could do 1400 degrees Fahrenheit and 0 PSI general purpose. But what they were doing before, they didn't know that you could do this. They didn't know there was something that could do that kind of temperature. What they used to do, they would take a rod. This is a glass making factory. They would take a rod and they would put it into the process, and they would just measure how much of the rod melted in the liquid that they had at 1400. That's how they did it. So this poor guy, this poor tech, had to come in, and open up a hot opening, right, and stick in a rod, and let it melt, and pull it back out. I'm really glad we were able to do this, and this is what the product was. Nick, you want to tell us a little bit more about the IntelliPoint and how many crazy hot applications you've done with it?
Yeah. Hi, Andrew. Thanks for having me. Yes, the point level for Drexelbrook, it's our bread and butter. It's a workhorse. So many different applications for it. And you named one application, high temperature. But it's not limited to just that. We've got thousands of different probes to choose from, depending on the application, whether it's corrosive, just plain water, liquid, granulars, but just a real workhorse, and provides point level and sensing and alarming features.
Yeah. So Nick is the regional sales manager from Drexelbrook, and he's been doing this for a while. And we see here on the screen, there's thousands of probes to choose from. I've been doing this for a few years. I've used quite a handful of those probes. And to Nick's point, yeah, this is a high temp application, but you can also see how many different places you can put the IntelliPoint. It's a very versatile product, and as far as I know, Drexelbrook is the only one that has so many different probes. They can do so many different applications. Is that right, Nick? Because most people have like one or two probes, right? Or like maybe a handful.
Yes, that's true. I mean, we pride ourselves in taking some of the tough applications, and that's probably what we're really good at. That sets us apart from the rest of the competition. So again, we take specific applications. We look at the application, and from the variety of probes that we have to select from, we make the proper fit for the application.
Yeah, so, I want to show some examples of that too. One feature that we have is coat shield. So it ignores the buildup. You can have virtually as much buildup as you can, as possible. And the Drexelbrook, the IntelliPoint is still going to work. There's no moving parts, so it's very durable. Nick sent me some pictures of some probes that were still working. Look, I mean, I don't even know what's on that thing. It looks kind of like a really hard donut, like a glazed donut, and that was still working in the process. What do they just have like an annual? Do they change it annually? Do you know? Or
yeah, I wasn't intimate with this application, but the story goes that this particular company, they swear by the Drexelbrook point level. They do an annual maintenance program, so they, regardless if the probes are working or not working, they always replace them. But in this case, this was working, but it was an example of how the buildup was on this probe, and yet it was still functioning and performing as specified.
That is pretty crazy. Looks like we got the right probe for that application if it's still working. And here was another picture. So this speaks to the coat shield technology. Also having the right probe, it's not degrading in the process. You have the same length of probe now as you did when you bought the thing, because it's we got the right material on this one as well. Can you explain, Nick, how that doesn't look like it should work? It looks like it's completely covered, and it should be reading, total. We've got level here, but we found a way to make this thing work. Can you describe the coat shield a little bit to us?
Yeah, I think, okay, here's a slide that illustrates that. Basically, it's a 3-terminal probe. We have the ground, the coat shield, and the active area. And depicted there is the area in red, which is the coat shield, and the blue area is the active area. So essentially, those two terminals are at the same potential. So there is no current flow back to ground. The only way we have flow is through the material. So when the material reaches the active area or touches the part of the probe, then we have a complete circuit from the probe through the material back to the tank. If you follow the blue lines there,
Yeah,
that
it looks
back to ground.
so it looks like the blue area is what's being measured, is what's telling us what the level is, and then that red area, which is closer to the tank, that's how that makes a lot of sense. That's how you can tell there's no path back to ground, i.e., there's no level being read. Yeah, and you can see this is exactly how it works. And in those applications, that's how it looked. It was totally covered, but the buildup didn't affect the reading. The level is below the probe. So yeah, I always find that fascinating, and I know that Drexelbrook, I think they invented the coat shield, if I'm not mistaken, right?
Yeah, we've got patents on it. I mean, there's others out there now, but again, we pride ourselves in that we patented the technology, and again, with the variety of different probes, we can provide the coat shield coating rejection feature.
This is for. Can this be used for continuous, or is this just a point level thing? The coat shield.
Well, we do it a little different with our Universal 4, which is a continuous probe. But we can provide coating rejection. We do it more electronically than we do as in the point level. Okay. But yes, in continuous, we can provide coating rejection or coat shield.
Cool. Well, thank you for that. Yeah, I know there's just so many different products we could talk about, and I appreciate we're hitting on the few good ones. But yeah, point level, continuous level, with thousands of probes, you've got a lot of applications you could mention. But another product that I wanted to talk today about was the ultrasonic, and how it's really a wastewater specialist. So this is the USonic and the USonic R, right? And the USonic R has has 2 different ultrasonics going into one sort of little controller. Is that right?
Yes.
Okay. And this was something that you helped me with one of my customers on this. So this is a wastewater OEM application. And all they needed was an ultrasonic 2-wire 4-to-20 output. And they didn't need anything else, really. And they needed a class 1 div 1 because that was what was on the spec. But that was it. And so when you look at the USonic R, that was where I started. And then I saw that we had a simple ultrasonic and even a blind transmitter. And so we ended up going with that one for this application. It was amazing to me how there's so many products out there, and wastewater is such a big industry. But to get a class 1 div 1 4-to-20 output, simple blind ultrasonic, it just ended up being the best price for the customer.
That's right. There's just a lot of value packed into this little instrument for right around $1,000 or so. So it's easy to configure, easy to set up, and as you said, it's got its own little display on it, so you don't need an HMI. I mean, you can obviously you're going to need something with possibly with the blind unit, but you want the integral unit. It's a well packaged sensor.
Yeah, and for open channel flow, they also wanted to have a high level and a low level alarm. So they wanted to have those relays. Nick, can you tell us exactly how did we do that? How did we solve that problem? Because the unit doesn't come with relays. Do you remember how we did that?
I'm trying to remember the application. Did we go through? I don't remember specifically, but
in this case, they ended up putting two little relays at their PLC.
Okay.
So yeah, so and I'm remembering that. So they used to have an HMI in the field that was a little more costly, and they needed it for the relays. In this case, we just had 4 to 20 output, and then it would go back, and the relays would send signals for high level or low level alarm, just to make sure that the channel was full of water. So that was the only thing we had to add, was two relays programmable at the PLC. So many people are doing PLC these days. Yeah, this is the little more information on the ultrasonic. So we can do up to 30 feet, 0.15% accuracy. That's the value you're talking about. I mean, that's pretty good. And you can do level, distance, flow, volume. I mean, for $1,000, I can't think to get much better than that.
No, it's quite a value. So
Yeah.
a lot of different applications, as you said. We've used them in wastewater, obviously, and there's been some other applications that some unique applications that it's found its way into. So just a nice little package.
And we would certainly be remiss if we didn't talk about all the radar Drexelbrook has. Nick, I know you've had a lot of applications with different types of radar, and I see we've got everything from 10 gigahertz all the way up to 80 gigahertz. And I'm noticing that this is sort of a trend with Drexelbrook. So you can really customize the probes. There's thousands of probes to choose from on the level, the point and continuous level probes. And it looks like on the radars, you've also got different options of different horns or cones that you can do that fit different applications. Can you talk a little bit about that?
Yeah, on some of the lower end units, well, even the 24 gigahertz units, we have it kind of evolved. It started out with the metallic horns, and they've served their purpose over the years, and they're still used. One of the issues with metallic horns is that sometimes you can get dust and condensation up in the horn, and it can interfere with the signal. And so typically they have to put a purge system in there to every so often intermittently purge out the area so that the it's a clean area in the horn. So that that's still available, and there are applications for that, and it works quite well. We did move to the 24 gigahertz with the drop antenna, and to eliminate unnecessary purging systems and condensation buildup, we went with what we call a drop antenna. And basically, if you have dust, moisture, or anything that accumulates on the antenna, just by gravity, it will fall off. You see in the center of the center picture there of the drop antenna.
Yeah, so it like collects at the
So
bottom.
that's served its purpose well. Sometimes the challenges are with dusty applications. We can sometimes, during a fill or something where there's a lot of dust, there could be interference. And so now with the onset of the 80 gigahertz, which includes a flush mount antenna, number one, we have a narrower beam angle. Number two, it's flush mounted. It doesn't necessarily have to protrude into the vessel, and it can actually be recessed. And then with the 80 gigahertz, we can burn through a lot of that dust. So it's evolved from the horn type antennas to the drop antennas to the flush mount antennas.
Yeah. Yeah, that the 80 sure has more kick to it than the others. Yeah, and here's some examples I just wanted to share. 10 gigahertz still has applications. It's not like 80 gigahertz is simply the best radar out there. Although it's very useful, there's still some applications for 10 and also 24. This is interesting. You're able to sort of move your signal in a sense. You can
Yes,
move
so this is a modular design with the 5200 series radar units, 10 gigahertz. Typically, we use those, as it says here, in storage applications. But it's modular design. We can mount the housing horizontally, vertically. And if you've got obstructions inside the tank that you want to work around, we can do that with some of the 90-degree bends and angles. And it works quite well. So it's very flexible for mounting and for avoiding some of the obstructions you might find in a particular vessel.
Yeah, and you'll certainly get a good signal strength. We'll talk a little bit more about signal strength in a moment, but for the right application, it's great. And I know we've already talked about this one. The 24 gigahertz for a long time has been what people have gone to because it has the higher frequency. It works well with things like agitation, and you can, as you mentioned, you can get different connections that will protrude into the process or not, however you need to do it. To make sure that the moisture or the dust is not an issue. And we have a fun example coming up, but I can't wait to talk about the 80 gigahertz. so this is the newest one, right?
Right. The industry has gone to the higher frequencies, 80 gigahertz. Key advantages are the narrow beam angle. So if we've got tight quarters to sense the level, we're not bouncing off the walls of the vessel or anything like that. We're able to get a tight beam angle in there and get a signal back, a good reflection back to the instrument.
Yeah.
And then, of course, with the 80 gigahertz, it's the higher frequency. We can burn through anything from dust to, we've got some non-metallic tanks. We can actually read right through the plastic tank and sense the level inside the tank without even putting an opening in the tank. So there's some applications out there for that.
That's like
it's amazing. It's the 80 gigahertz it's the industry trend, and it's not the always the best choice, but it certainly fits in a lot of difficult applications and solves a lot of application issues that you might run into with the lower frequency units.
Did you say you can read through plastic? So
we have applications out there that if it's a non-metallic tank, and we need to know a little bit more about the tank, but we can literally read right through the wall of the tank down to the level of the material inside the tank.
Yeah, and just kind of map out the tank. That's like the ultimate non-contact. You don't even need to drill a hole. You just go right through it. That's amazing.
Exactly.
So yeah, and you've touched on this too. Which radar is best? So we do offer all of them, and here's one of the differences between them in that the beam angle and the power of that signal shooting down and then bouncing back up to the radar, that's different for each gigahertz. And as you've mentioned, yeah, that there are some things you can do with the 10 gigahertz that you can't do with the 24 or the 80. And when it comes down to picking which one is best, not only is Nick an expert, but I will tell you, I've worked with Nick for a few years. He has, in his opinions initially, been wrong. I know this is surprising, but here's what I'm sorry, I thought we had the next. Here's what we do to make sure that even when we think we're wrong, the customer does not lose any money and they get the right application, they get the right product. Nick, can you talk about the QR1? This is, I think, the best guarantee probably in the industry today.
Yeah, we call it the process verification form. And basically, we just try to gather as much information on the application as possible. Ask, for a new application, ask that this be completed as complete as you can with some sketches and drawings. And then we'll review that. The factory will review it with our application engineers. And you can request the technology, for instance, if you wanted radar, and we could certainly specify something in our radar selection, or in some cases we may come back and say we think the best fit might be capacitance probe, continuous feedback. But what this does is that we get all the facts, we make the specifications, and provide a quotation for what we think is the best fit. If for any reason, after we've reviewed your application based on the information provided on the process verification form, it doesn't work, then we'll work to either provide a product that will work for the application, or in the end, if it doesn't work, which is hardly ever the case, we'll provide your money back.
Yeah.
So,
Mhm.
it's a win-win for everybody.
Yeah, I've actually had this happen with some of my customers, and I've also heard about it with others. It works or your money back. It really is, and it's that simple. If once we have all the data, as long as the data provided is correct, and I'm usually your salesman will help you provide the data for the application. If it works, great, and the factory's reviewed it. But if not, I have seen you guys. You simply take the return, and you try and get the right thing. You try and make it right. And it's rare that that happens, but the customer really does get their money back.
Right, and we'll even take it a step further if necessary. We'll come out and work with the customer and set up if there's some initial configuration or setup. We'll come out and do that. In some cases, if we have to send out a factory service engineer, we'll certainly do that as well. So
yeah,
we provide a lot of what we pride ourselves in is we provide a lot of support rather than just providing a product and say, here you go. We do a lot of upfront engineering with you, and then provide the necessary backup and support once it's installed.
Yeah, you were telling me about this example of a silo filled with lime, which sounds like a very pretty application. No, you can see right here the picture on the right. That's the 80 gigahertz Drexelbrook radar unit after it's had some use in the silo. And they were having trouble with this, right? They started. What did they start using?
I think they were using a guided wave radar, and it wasn't working very well. They were having intermittent problems, and finally they took a look at in this case, it was the 80 gigahertz. It was a DR6500, and we mounted it, did a little initial upfront configuration, and seems to be working quite well now. So, and this was one of, I think there's several more tanks that they're looking at. So it's
Okay, good.
It's really a nice application, and it's a real powdery, dusty application, I might add. So particularly when they're filling, I think this picture shows the truck filling. When a truck is filling, I mean, it's kicking up a lot of dust in there.
Okay.
And they also have a purge system inside the tank that they every once in a while blow air into to keep it's kind of a what they call a fluidized bed, and to keep it, because it's so fine, keep it fluffed up. And so
Okay.
but at any rate, it's a good application for the 80 gigahertz works quite well for them.
Yeah.
And it's non-contact, and you don't have a cable protruding down into the tank.
I can imagine, and with something like this, if you've got purge going on and possibly other things happening, the fewer protrusions into the tank, the better. That's great that the 80 gigahertz worked, even though the guided wave. It must have been a very long cable for the guided wave.
I think the cable was, if I'm not mistaken, it's probably about a 30, 40-foot tank.
Okay, yeah. So to get that out of there and have no issues with the 80, that's good. So, and yeah, I know, Nick, you went out, you adjusted this one, you played with the gain, and you made sure everything was working. You made the 80 gigahertz work. So not only did the factory recommend it, Nick then came out and adjusted it to make sure it was really the right fit. So, well, thank you, Nick. I think we've covered just about everything. The only other thing I want to mention is that we haven't covered some of the other products that Drexelbrook offers. And JMI, we're happy to be a complete level solution for our customers. This is really just the tip of the iceberg for what we can provide and the expertise we can provide for all the different level technologies. With that, I would like to say thank you for those of you who have tuned in and those of you watching on YouTube. This has been another episode of JMI TV, and hope you guys enjoyed it. We'll see you out there.
Thanks, Andrew.
Thanks, Nick.